Do you need me to share screen or do you want me to just take a screenshot?
If you already know what you want to ask, I think screenshotting will be more effective because I have to write in the Jamboard anyway.
Okay, I think I'll just screenshot to you if I need to ask something. Okay.
We use the, what's the previous Jamboard? Whatever, let's just use the previous Jamboard, right?
Previous one, okay.
Okay. Right.
Sorry. I have the Tuesday one, but
You
do you want
have
me to use the Tuesday one or the previous one? Like,
the Tuesday one is like not used at all, right?
yeah, not use at all.
We can use the previous one, which is where.
Okay, sure.
Anu, if you have made the new Jamboard, I'll follow. If not, we can use the previous one also. Oh, you have. Okay.
You use the previous one.
Okay, let's do that. Okay, Joshua, I am going to the 0706, is it? 7 June.
Yeah.
Okay, then the 13 one I just delete, can? Easier.
Okay, sure.
Okay, right. So Anu, just to confirm, back then you were asking me any book references for you to do, right? And actually my answer is you should be trying out the SA2 papers instead. I feel that is the right thing to do, right? That was my answer actually.
Yeah.
Are you satisfied with that answer right now?
Yeah.
Right. Let's continue doing that because because it'll be good. Okay. Have you finished? Oh, you haven't. We have not talked about the Venn diagram, right? That's like the new topic, correct? Am I correct?
Yeah.
So we can talk about page 8 and 9. So which one do you want first? The page 10 one or the 8 and 9? That's up to you.
Before that, from the previous lesson, the answer was wrong.
Which one? Which one is wrong? Sorry, which one?
Page 7.
Page 7. Okay, let's see page 7. Right. So why is the answer 4520? Is it?
Yeah.
Because it's 3SF.
Sorry?
Yeah, because it's 3 significant figure.
Oh, okay.
Yeah. So that means your answer was correct. You just didn't make it 3SF. Something like that.
Yeah.
Do you have to 3SF? Yeah, unless they specify otherwise, like you 3SF. But yeah, something like that. Okay. Now, which one do you want to talk about?
Page 10 first.
Sure thing. Now, what do you want about page 10? This is the first time you, yeah, I think maybe. Oh, no. This is a long time ago, right? Long time ago. Yeah, this is not terribly easy. Do you want me to demonstrate using the table method?
Yeah.
So I'll do it. Okay. So, okay, Joshua, you put in, I'll answer Anu's question first. Yeah. Okay. Yeah. Nice. Okay, the rest. Yeah, it's not very easy, right? Okay, so now what we want is to put everything in, of course, but to put everything nicely. So I put x here, but I'm more interested in 2x plus 1, correct? Next to y, because these are the one with inverse proportion, correct? 2x plus 1 and y. Okay, so I'll put my x here because he tells me 0.5 and then 2. And then I immediately go to this bracket because this 2 bracket is what I want. Are you following me so far?
Yeah.
Okay, so now I will have 2 instead here, and then I will have 5 instead here, correct? Yeah. Then he wants minus 0.25, right? He wants that, and then he wants a question mark here. Okay. And then now he tells you the difference. The difference is the new thing here. The difference means from here to here, it is no longer times or divide. We're looking for we're looking mainly for times. We are happy when it is times, correct? But turns out that he does not give us times, he gives us a plus law, the difference in the value of y when this, okay, first of all, this is, I'll call this y1 and I'll call this y2. Will this be okay?
Yeah.
So, and then I will notice that y1 will be smaller, no, sorry, will be greater than y2. I noticed that. Do you realize that?
Okay.
Why is that so? Because this is going up. Therefore, this must be going down. So y1 is bigger than y2. That's already something we have to realize at the start. Isn't it? Can you accept that?
Yeah.
Okay, so I'll call this bigger and call this smaller. So that's why. And then therefore, I know that this is going to be minus 0.9 instead of positive 0.9. Positive 0.9 will be wrong. And that's why I make a big deal out of it. I need to know. Okay, again, the minus is new and we are not really sure how to deal with it because we are used to dealing with it with, obviously here, times 5/2 lah. We are used to doing that. So by right, this should be times 2/5, isn't it? By right lah. By right. But we cannot do anything with it right now. So what can we do lah? So this is the situation right now. If you have any question at this point, please ask first.
Oh, no questions.
Right, so now, how do we deal with all this, right? So, shall we go back to the, maybe, no, there's no point. There's no point. So I'm going to write this down this way, right? So, y1 minus y2 equals to 0.9, okay?
Yeah.
y1 times 2/5 equals to y2.
Yeah.
Do you recognize two equation, two unknown?
Yeah.
I can solve it. Does it make sense? I can go and find y1 and y2 using these two equations. Can you do it? Now the question is no joke, though. Really no joke. Now, if you can, please give it a try. If not, please tell me. Right. So Joshua, I see one question, only one question right now. Huh? Yes.
2. Page 8 and 9.
8, 8, 8. Right. So okay, let me go and 8. Okay, right.
I haven't checked out the rest yet. That's why I didn't.
No problem. No problem. So tell me what's your problem with 8.
I don't know how to like start to explain in like scientific terms, I guess.
But you tell me your thinking first lah. No need the fancy
Okay.
thing.
Let me try.
Okay.
In terms of forces. Oh, is it like because they fall, right? And then because of the air resistance.
Okay, wait.
Is it? I don't know.
Wait. I know you want to aim to forces, but remember this is 3 marks, right? Okay, so maybe we should start with force. Maybe we should start with something else. You have to at least be open to that.
Okay.
What makes more sense from the graph, right? Because in the end, we're explaining the graph, and the graph has neither force nor velocity. Now, this graph is displacement over time. Okay, so which one is closer to the graph? The velocity, the force, or I don't know, something else?
Velocity?
Then I think at the very least, you must start from velocity. That means make it clear first. Make clear your mind on velocity first. How do you see the velocity in a displacement graph? You see the
gradient.
So I'll just visually do it for you. Then there's a gradient, there's a gradient. Okay. So now explain it in terms of the velocity first.
It decelerates from at 0 seconds.
Fine. If what you mean is this is negative, right? This is a negative.
Yeah. Negative velocity.
And this is more negative. More negative.
Yeah.
And this is now a constant negative, correct? would, I think, disagree with the choice of X deceleration. This is becoming more negative. The velocity is becoming more negative. Let me put it this way. Let's say this is minus 2 meters per second and this is minus 4 meters per second. Let's pretend that forward. Would you call this deceleration? Think carefully, yeah?
Oh, I see what you mean. Okay.
Becoming more minus doesn't necessarily mean deceleration is the best word. Because this is clearly, let's say negative is going to the left, right? Correct or not? That's what negative velocity means. It doesn't mean it's negative. It means it's going to the left, okay, for example. So I'm going to the left faster, you know. I wouldn't call that a deceleration. It's very confusing for myself. Yeah, does that make sense? Right? Now, having said that, I applaud your effort. You go from velocity to acceleration. Now, why do you want to do that?
Because it connects with it links with the, what do you call that? The
one, which is
resultant force.
Yes. Which is you're right lah. From velocity to forces or resultant force, you go through A. Correct. So it's not that you're wrong. Conceptually, you're right, I think. So given all that, do you still need my help or would you like to try yourself?
Okay, hold on.
No shame is asking help. No shame.
Okay. Wait, but it says here okay, so the gradient here is like, oh, okay. Gradient here is less steep, and this starts to get steeper.
Negative into more negative. Just
so
say
it's quote unquote accelerating, but like in the opposite direction.
Yeah, that's what you need to see with the sign negative. It's not a negative, it's the other direction, correct lah? The other direction. So, you know, to make your life easier, I'll suggest something, right? Just assume you can start from you can open your sentence like assume positive is to the right and negative is to the left. That is actually a very reasonable thing to say. So go ahead, type that thing first. Positive is to the left, to the right, and negative is to the left. Just write it down first. See whether it makes a difference or not. Okay, go ahead and type it.
Okay.
Anu, are you stuck with the simultaneous?
Yeah.
Okay, now think carefully about your concept of simultaneous. Okay, let's expand it. The concept of simultaneous is very simple. You have two unknown with two equations, correct? Whatever you do, you're going to make those two into one. One more time. Two equation, two unknown. Your goal is to do whatever it takes so that it becomes one equation and one unknown. Whether by elimination, substitution, whatever not, that is the goal. Clear so far?
Yeah.
Okay, so let's call the first guy equation 1 and the second guy equation 2. I'll ask you like this lah. Is it easier to go 2 into 1 or to go 1 into 2, you know, in order to make it one equation, one unknown?
2 into 1.
Which one?
2 into 1.
I would agree with you. I would agree with you totally. Why don't you do that?
Okay.
Do that and you'll be fine. Okay. Now, again, Joshua, I'm saying that this simple opening will help you explain much more smoother. That's fine. Yeah, both is also fine. But I think I will just choose one. I'll actually above the ground. Oh, then that means it's not left and right. We should be using up and down. You understand?
Okay.
Makes sense, huh? So the to right is not useful here. The up to down will be very useful.
Oh wait. Okay.
So try commenting about the velocity and the acceleration using up and down instead of positive and negative is what I'm trying to say. Give it a try.
It increases in speed. Right?
Well, you just say this one. The velocity downward, right? The velocity downward starts from 0 and accelerates. Does that make sense?
Yeah.
Okay. Right now, I mean, I'm using a very compact sentence because I'm experienced, but I mean, you can try that, but try to understand the sentence first. Try to see how well it serves you, right? Velocity downward starts from 0 and accelerates.
So starts from 0, accelerates. So that means when it accelerates, the resultant force, there's a resultant force down.
No. You have to analyze the acceleration. Oh, it's not easy at all. It's not easy at all, right? It's not easy at all. It's not easy at all to accelerate the acceleration using displacement graph, right? So just say the velocity first. I think you're really jumping the gun. You're really jumping the gun here. So just say the velocity first, right? The velocity downward accelerates from 0 velocity to a constant velocity. You can say, at least say that first, correct?
Yeah.
At least say that first, stop, and then we'll go analyze the acceleration, and then the force will be easy.
Okay, and then the paper continues to follow with a constant acceleration. With a constant velocity.
Okay. Not constant acceleration, constant velocity. Type it down first. Type it down.
Well, let me type it on.
Okay. Right. Okay, Anu, feeling good so far, Anu? Okay. Anu, okay so far? Anu? Oh, yeah, good. Okay. Oh, yeah. It's not a constant acceleration. It's a constant velocity. One more time, Joshua. We will have great difficulty reading acceleration from a displacement graph. That's why this question is terrible. You cannot read the velocity first. Yeah. Okay, before reaching the graph. So far, so good.
Okay.
You have analyzed the velocity, and let me just state first, it is nearly impossible to analyze the acceleration from a displacement graph. Normally, you will draw the velocity graph first, and then you analyze acceleration then. You understand me? This is not an easy thing to do. It's not a normal thing to do. If you want to, you can use a sketch, right? Go ahead if you want. That's always the easier way.
No, that's like.
Oh, goodness me. No, Anu. No. This one I like. This one not sure. This one is useful, but it's okay. This one is totally wrong. Yeah. So let me ask you to imagine this way, Anu. Let's pretend that this is x, easier. Let's pretend for a while is x, and this is now 2/5x. You follow? Let's pretend for a while. No mind, I'll use a instead. A, and this is 2/5a. Okay. What is a minus 2 over 5a?
3 over 5a.
Yeah. Now look at your answer. Is this, well, so to speak, 3 over 5? Is it?
No.
Okay, so Joshua, in order to analyze the acceleration, if you really want to use the drawing method, it is much better to align it with this. Yeah, so align like that. Then you're not very confused. Okay. Okay, so try again, but align it using the like precisely like that. Yeah, it's easier like easier.
Okay.
Right. So okay, I see what you're doing. Yeah, I know at this point you could find the y1 already, right? So Joshua, are you saying that the acceleration starts from 0 and it goes to a negative value? Is that what you're saying?
I mean, like it's going to the opposite direction because it's the displacement is going to the opposite direction. So I meant like I thought like if you make it like if you make it like this, and then you do something like that, I don't think this will be right because it means it's going this way.
Okay. Now, let me now try to analyze it from the velocity perspective, not the displacement perspective. One more time. Actually, don't analyze acceleration from displacement. Don't analyze acceleration from velocity. So one more time, to make our life easier, give a value. Now this is 0, correct? 0 meter per second. The velocity is there, correct? Let's start. Would that be okay?
Okay.
Then here it's we'll call it -2, and and then to just help ourselves, these are all made up numbers. This will be -4, correct?
Okay.
Then since the velocity is constant here, the velocity is the gradient is constant, the same here and here. So therefore the velocity here is roughly
4 -4.
Because the velocity is constant. It never changes after a certain point. Now look at your analysis. Now I'm analyzing it based on the velocity, not the displacement. From here to here, there is no change in velocity, and yet say there is an acceleration. Does that make sense? The velocity never changes. It's -4 to -4, -4 to -4, -4. And you say the acceleration is a certain number. Again, does that make sense? Isn't acceleration the change of velocity, right?
Okay.
So if you have an acceleration, your velocity should be changing. And yet your velocity is not changing.
Wait, but like isn't this part on? Isn't this part like showing the acceleration? Because after that it's constant, right?
Okay, one more time. Look at this point. You're saying that at this point, the acceleration is 0. And yet,
Mhm.
when I see this is zero velocity, not acceleration. I see that
Mhm.
this zero quickly changed to another number in front of him. This zero will change. This -4 will not, correct?
Okay.
So to call this an acceleration zero means you are saying that the zero is not changing. That I don't think is correct.
Okay.
-4 and accelerating, I don't think is correct also, because the -4 never changes after this point. Let me put it another way. I'll do it this way. I'll do this part acceleration 0. Okay, I'll do it the other way.
Mm.
And then I'll call the other part, okay, something like this.
Oh.
Acceleration, which starts off with something and then reduces until it is 0. Acceleration and not velocity. Yeah.
Oh, we're going straight to acceleration. Oh, okay.
We're going the velocity. Oh my goodness. What am I talking about? What am I talking? Sorry.
Oh.
This is me confusing you. I forget that you're drawing the velocity, right? I totally forgot. What am I saying? You're correct, lah. No, you're absolutely correct, lah. You're absolutely correct. Now let's talk about acceleration. You're absolutely correct.
Okay. It's good. Okay. So from here, acceleration 0. Down.
Okay, Anu, you have the y1 as 1.5. So you have the y2, lah, correct? You have the y1 and then you have the y2. Correct, 1.0.6. Are you okay so far? We're very close to the final answer.
Yeah.
So do you know what to do to get? Well, we'll call this y3 lah. Make sense? Y3. What will you get? What will you do to get y3? Is our previous skill enough, or do we need, new things lah? What do you think?
I think we need to find a constant.
But in the table method, we never care about the constant. But you can find the constant if you want to. Lah. But in the table method, it never matters. Remember the table method? Everything depends on this thing and this thing. That's on the arrow. So there will be, minus, which is minus, which is 0.5. All right. Then you have a arrow here. Look. This arrow will be Joshua, are you okay so far? Right.
Yep. And to write the, what do you call that? The
Analyzing the
acceleration.
Right.
Yeah. So from this part, right? This part, there is acceleration.
Yeah.
And then from
rather big. Yep.
And then from this part, there's 0. That means like the air resistance. Is there air resistance?
So the acceleration? No, cannot say resistance. You must say acceleration is
Constant.
Decreasing. The acceleration is decreasing until it is 0.
Oh, okay.
Therefore, the sigma f is start off big, and then decreasing until it is 0. It is because the air resistance start off from 0 and increases until it matches weight.
Okay. Okay. Well,
So times 10, right, Anu? So the answer for y3 should be 6 lah.
Oh.
Am I correct? The answer for y3 should be 6, but does that make sense?
Yeah.
No, not 10, but 6.
Yeah.
Maybe you're not fully sure yet. Maybe you check the answer key first, see whether it's correct.
Yeah, it's correct.
Okay. Now you have a few options. I'll tell you first that this is very unlikely to happen in exam. Very unlikely. Very unlikely. This is crazy. Nobody can do this. Not a lot of people can do this in exam. Huh? So I suggest if you're still interested, well, you erase the working and do it again. And if you like, I will also demonstrate how to do it if we go and find the K first. I'll demonstrate 2 ways for you. If you want, because it'll take time. Yeah? If you want, we have time. You should do it. Okay. So if you want, again, erase or rather do the working one more time so that you are certain first without K, and then I'll demonstrate to you K. Right? Okay, try. Joshua, are you feeling good so far?
writing down my answers on the worksheet. I think I'm okay. Yeah.
Joshua, are you writing it somewhere? Okay.
Oh yeah, I'm writing it in somewhere else. So
Oh, right. If
Yeah.
you're okay.
I'm okay with that. I'm okay.
Once you're ready to move on, you tell me. Yeah? Anu, are you okay?
Not really.
Okay. The table is going on definitely fine. Everything you're writing is totally fine. Your writing is totally fine. Everything is totally correct. So the only thing that's confusing to me is that you know that this is important. I believe you should be using this one. That this two arrow has always been the central thing in the whatever this table method. So use it. Use it. We're doing fine.
Sorry, can you look at page 10 real? Yeah.
Yes. Okay.
It says the atmospheric pressure, right? So do I follow I should follow the 51, right? The 50 mm.
No.
Oh, sorry.
No.
No?
It's going to be, so the atmospheric pressure, imagine the atmospheric pressure is here, right? Okay. So here is pushing the same atmosphere, the pressure. So this pressure is being countered by this pressure. So that's why nobody is moving. Okay.
Okay.
If you want to know this guy, you find this guy. Okay.
Okay.
To find this guy, you find, well, first of all, the length of the liquid first. The length of this liquid is definitely not 50 lah.
Oh, okay. That's 7,
That would be
800 minus 50, 750.
Yeah, so we just say clearly the 750 mm, right, Hg. This is a very valid unit of pressure. That's how you should write down.
Okay.
Right? So the moment I see the length 75 mm, I just add Hg, which is the liquid, and then everybody's very happy.
Okay. Okay.
At this point, Anu, you know what's going on. This now it's easier, right? Good. So Anu, I've written for you the method with K. It looks very short. However, it's not that easy to understand one. Okay. Okay. Are you ready? This one is correct. Do you understand the second line? Oh my goodness, the second line takes quite a lot of effort to write.
Um,
understand that, then you can find K. Just whack here, whack there, you can find K, and then you will use K, and then you're done. If you can understand this, definitely it seems shorter. But I would propose that you choose whichever method that you find easiest to understand, not necessarily the shortest line. Would you like to try the K method? Joshua, are you okay so far? Which one are you doing right now? Sorry, Joshua.
The barometer question. There's still some calculation.
Which one? You mean you are done with page 9 and page 10, really?
9 is.
I draw the explanation, but do you understand?
Hold on. Let me see.
Yeah. They're not basic questions. That one we can say. You know.
I don't understand question of the page 9.
Okay. The explanation goes like this. Nobody do horizontal, okay? Nobody. So this question is unique, right? But in the horizontal state, the force balance, easier to explain with force. The force balance is whatever pushing to the left, the same with whatever pushing to the right.
Okay.
What is pushing to the right?
Atmospheric pressure, I guess. Then.
So the only thing pushing back to the left is, well, the airline. Therefore, 75 law.
Okay.
Makes sense? The mercury doesn't play a part, is what we're trying to say. No, the mercury is just standing there.
Yeah.
The same, the similar analysis in diagram 2, but up and down. You will also never see air below. Such a tricky question, right? What nonsense is this, right? Who does this? Well, I mean, most of the time the air is above there, right? Most of the time, right? But the analysis is also quite simple. It's force. Who is pushing down?
Atmospheric pressure.
And don't forget.
Mercury.
And who is pushing up?
Trapped air.
Therefore,
they all equal to each other, and then.
Therefore, the air will be, well, 87. Bigger pressure than 75 obviously.
Okay.
The math is simple. The physics is important. The math is just add here, minus there, whatever.
Okay.
Yeah, okay. Very tricky question, right? Of course, but understand it as forces. Right. Page 10, okay.
Page 10, okay.
Now, Anu, once you find K, do you know how to use K? Correct. Nice. Yep. Just put in the yep. And you will be correct. It will be 6 also. Whichever you like, I hope you understand both. Then you have a bigger perspective. Yeah. Is this a difficult question? Of course. It's very easy to mess this up. It's also very easy to mess this up. Once you mess this up or mess this up, everything is just gone.
Yeah.
But it's a very good question. Now, what should we do next?
I will page 8 or page 9.
Okay, so it's a new topic, yeah. Let me just confirm. You have gone through a lot of, right? You've gone through the mensuration, the cylinder thingy. You've gone through pattern. You've gone through statistics, right, and everything. Just to confirm, are you okay with yet another new topic?
Yeah.
Sure. It's not supposed to be a very difficult topic. So now, okay. For all the weird things, this is extremely easy. Okay, yeah. Let me see. Let me break it down for you. This thing is read as the universe. The universe is simply the big box. The big box has nothing else outside. The universe is the universal, the biggest guy. P is the Venn diagram inside the universe. It'll contain sum of the universe, and R is inside P. So it'll contain sum of P, right? So let me show you the member of the universe. The member of universe is read this way. I will put it more like this. Dot 30, just to make it slightly clearer. Will this be okay? Now A, I will go and specify everything for myself because I find this to be not workable. I have to make this easier to work with. I think everybody has to do that. Yeah, I think nobody is like, should risk it lah without doing it. Right? So as a model of 3 and bigger than 6. So should I start with 6?
Yeah.
Okay, did I miss anything?
No.
Okay. What is B then? Oh, I'm sorry, this. Oh, I'm sorry, this is not connected. So it's connected. Okay. So what is B? Or why?
Oh, is it just the value of x?
Yeah. Because what he say is B contains x where where this is correct. Then it must be false. A contains x where x is a multiple. Then this one. Right. Would that be okay so far?
Yeah.
So C should also be easy to do. X is where x is a positive integer such as the. So do you know how to handle inequality? Let me refresh.
Yeah, probably.
Probably, maybe from sec 1, maybe there is. So nothing very complicated so far. Okay.
Yeah.
So I will still spell it out though. 1, 2, dot until this is 5.5, right? Yeah, I'll just write down everything. 5. Okay. Nothing complicated, but this is my preparation work before doing this. I don't think there is a person who can do it without the preparation work. I might be wrong. There might be some geniuses. I know I can't. I know I have to spell it out. Okay. Before that, Joshua, are you okay? You are still looking for questions. Yeah?
Sorry, I'm a bit stuck on this one. I think we went through it last time, but I think I forgot a bit of the.
So how to change this to Pascal, right?
Oh no, the
Extremely simple one. Rho GH.
no, not that one. This one. Hold on.
I cannot see.
This one. I forgot how to do it. This is bad.
Enclosed air. Okay, again. Right.
Enclosed air. 150, right? 150 mm. From here to here, and then this one's here 150, right?
That is definitely 150. Yep, that's definitely 150.
And then like this one is exerts the same pressure as the liquid, as the mercury.
Right. So the air trap must be doing the same thing as the 150 mercury lah.
Yeah. So rho G is 10
Right.
Row, it will be the same. Oh yeah, Mercury. Okay, never mind. Got it. Okay.
So as long as you know 150, you're on the right track already. You're correct already. At this point, I think you're already starting to get it. In the drawing
Yeah,
the
yeah.
lines and all those stuff, you're thinking about right already. Okay, good. It's not easy, it's not easy. Okay, so Anu, now I will explain what these two symbol means. There's only two symbol, three, this, and then that one. Okay, so this symbol looks like an N. Looks like an N. You remember that way? N intersect. Okay. Oh, there's no union. So I better explain. So this one looks like a U, looks like a U and union. They are only intersect or union. So now he asks you for B intersect C. It's very simple. What is inside B and C at the same time? That's what intersection means.
Which part is A, B, or C?
Which one? Sorry, which one?
Which part is A, B, or C? Like, which part of the Venn diagram?
A is okay. I'm sorry. So I forgot to mention that this has nothing to do with this. It has nothing. There's nothing to do. Like this is just unrelated to this guy. Are totally unrelated. Because this is P and R. This has no P and R. There's A, B, C. You know, they are just unrelated. It's just confusing. I'll answer the part A later. Okay.
Yeah. Okay.
So now B intersect C again, meaning intersection simply means what is inside both B and C. It's very easy to see the answer. So the answer will be yeah, like that. So second question should also be answerable. What is intersecting A and B? So what is in both?
It's like 12 or something.
No, it's nothing.
Oh.
Can you accept that? There is nothing that intersects A and B. I mean, it's easy, right? B is 4. I mean, is there 4 here? No, that. Okay, so how do you say nothing? You cannot write nothing. You know, there's a fancier way to do it in math. Either you do this is nothing, a slash O, a slash 0, or an empty bracket like that, or an empty. That's called nothing. 0 is not the right answer. 0 is considered a number. Don't answer it with 0. 0 is not nothing, if you can accept that. Okay. Yes. Now, this is union. So union is not intersect. Union is just combine both. Simple. That's what union means. Combine both. Easy. So combine both A and B. Not difficult, right? For 6. That's a combination of A and B. Correct?
So I just say 4 and then like on the rest of the number, like 6, 9, 12, everything.
Right. That's what A union B means. Now, hold your horse. This is prime. It means not. So what is not A union B? At the risk of over explaining, what is not A union B is 1, 2, 3, 5, 7, 8, 10, 11. You know that kind of thing? Do you understand, Anu?
Oh, so it's like the numbers that's not in 10.
Yeah, precisely the word not, precisely the word not, the opposite or the not, right?
Okay.
Not complicated. And then lastly, hold your horses. The small n in front simply means the amount of member. So he's not interested in the member. For example, in part 1, he wants the answer for lah. For part 2, he wants the answer, nothing. For part 3, he doesn't want you to list down the member. Okay, he knows it's very long. Just tell him how many member is there. Let me give you an example. the number of member of B is just one loop, right? And B is one, correct?
Mm.
What is the number of member of C? And C is
5.
then the number of member of A?
30.
No, it's not 30. No, count again. No. A is not 30 member. No, wrong.
Oh, A, sorry. 9.
9. 1, 2, 3, 4, 5, 6, 7. Yeah, I agree. Then, of course, the number of member of the universe is 30, right?
Yeah.
So, what is the number of member of not A union B? That's a mouthful, but it's not very hard, right? Joshua, are you okay? So,
I'm very much stuck on.
but I don't see any question right now.
Sorry. Yeah, I was just trying to solve it earlier on my own, but
No problem. No problem.
yeah.
It's a difficult question. Let's talk about it, right?
I don't think it's difficult. I think it's just some.
Show it to me first. Show it to me.
Yeah, sure.
I won't tell you immediately. I won't. I never do that one. Never, right? Okay. Aiden, I can see you. Yeah, please wait for a while. Okay. Anu, what is the amount of member of A union B not?
20.
Because the member of A union B is 10. So not must be 20. Right? Perhaps to your surprise, you almost get 70% of the topic already. The rest of 30% is here. So you are kind of can try already. Can try. Maybe we wait for the 30% next week, and then that's basically all the new topic. There shouldn't be another one. Right? Doesn't mean that you can do them very well, but it means that you can practice them already. Okay. Any question on this new topics so far?
Do we always have to write the bracket?
Yes, that special bracket is used especially for this.
Yeah, then no more questions.
You will learn, if there are more formalities to learn, you learn them from your teacher. Really good job for today. We will finish this topic hopefully next week, and then we'll try some, and then it'll be school day. It'll be okay. All right. Okay, Anu, I will see you next week.
Thank you. Bye-bye.
Okay, Aiden. Mr. Aiden.
Yes.
A decision time. What do you want to do right now? I can spell you the options if you want.
You said it's either chemistry or physics, right?
Correct. Chemistry would be, you are revising many things. Right? You realize that? You have revised the acid base and solubility, right? You have revised your QA a little bit, but enough for do exam. You have done the mole question a lot, so you already know that future topic. You have not done ammonia, and I think I'll leave it to the teacher for now. That is why you can do many of the paper questions. You can at least try them. That's your state of chemistry right now. Okay. So very important. Either do more paper or do ammonia or whatever. Right? You're saying, sorry?
So do you think I should like move on to physics now, or should I still like perfect the chemistry part?
I think you can perfect it during school days. There is no harm.
Okay.
You need to perfect it through, but I mean, not that rush, right? You may want to go to physics first. That would probably be, I mean, I would feel better because I then know where you are, because I don't know where you are.
Okay.
Okay, so go to Jamboard first, if that is your decision, right? Go to Jamboard. It is up to you whether you want to separate the chemistry and the physics Jamboard. Remember, it is your Jamboard. Now make a decision. Do you separate them or not?
I think that I'll separate it.
Then when you separate, please, August, name your name, but also put chemistry and physics in front. Please do that. Okay. And then you share with me your physics Jamboard, then I can go in. Every time you share, you must tell me so that I can go in.
Yeah.
Okay, so Joshua. Yes, this kind of question. So let me clarify first. You should be familiar, Joshua. This is the one area bigger, one area smaller, same pressure all the way.
Yeah.
So
Same pressure all the way, and then A2 is bigger than A1, right? So when you multiply,
therefore a F2 should be bigger than F1. Now a
Yeah.
bit of clarification. If this is 2, then this must be 2, right? Carefully.
hold on.
It cannot be 1 and 2. That doesn't seem to make sense.
Oh yeah, okay. Yeah, I thought, yeah.
Now, obviously, you have never seen this device before. You may not even recognize it in real life, but we still have to know how it works. Quite a challenge, isn't it? Quite a challenge.
Mm.
So the question is very simple. Does the thing make sense to you? That's the important thing.
It does make sense, but I can't like word it
Tell me.
without the
You tell me why it makes sense just using your own opinion. Okay? Never mind fancy numbers. Fancy.
Okay, so like
Mhm.
the pressure made by the force is the same, right?
Yeah.
And then
Mhm.
so it uses like a surface area.
Just a minute, sorry.
Um,
I see your Jamboard already, right? I see your
Yeah, I
Jamboard.
sent you already.
I need you to do something very similar to chemistry. Like you're gonna tell me, okay, is there any exam coming? If you know what's the topic, if you don't know, then at least tell me what you have learned and what you're gonna learn. Whatever you know, that will be very helpful.
Okay.
Could you type for me in the Jamboard? Right? It'll be useful for me. Right. So back to you, Joshua. So your pressure is the same. Then what? Small surface area. Then what?
small surface area. Then the same pressure
Throughout the oil, yes.
throughout the oil has to be produced at a larger surface area.
Okay, now here's where it makes sense or not.
Uh,
You are the operator, right? You're the human being, right? Operator is human being. You're giving a force. The large piston is the one doing, blah, blah, blah. And then at the large piston, the force is greater or smaller?
It's greater.
And in that sense, is this device useful or makes sense or useful in that way?
Yes.
Because if you give your normal human force, you get a greater force, and this device seems to be able to do what?
To lift cars.
Which obviously we cannot do.
Yeah.
With the help of this device, hopefully we can. Okay. Why does this make sense in another way is I tell you, the operator will move far, but with lesser force. The large piston will move with a larger force, but less distance. This one is not described or explained by the teacher usually. I will do that. Okay.
Huh?
Is small force over long distance giving you large force over small distances. There's no free lunch. Okay, but I will take that trade. I will take that trade. The reason is very simple. The oil here is less, man. You move this oil,
Yeah.
oil enter to a bigger one. So the oil has
Okay.
because it has to fill the bigger chamber. But
Yeah.
you will still take the trade one. You will still want that. So you cannot lift the car as high as you move, but you will lift the car. That's the trade-off. Again, to me, I'll take the trade-off.
Okay.
Now, the explanation is fine. There's no need. I mean, your explanation is already correct, according to the formula F over A and pressure along the way. So if A grows bigger, F2 must grow bigger. That's the explanation. That's it. You already understand what.
But I cannot like word it, if you know what I mean. You can't use formula, right, and explanation.
You can.
You can? Okay.
Nice. Not just you can, they will like it more. So let me show this way. Because this, you can write down because this and this Therefore, this. No, done. You finish. You're a very happy one. Guarantee you. I guarantee you that. You want to word that into English? Up to you. You don't have to in physics. You don't have to at all. So
Okay.
let's take this carefully. Yeah? Explanation in physics can be in the form of formula. They like it. Explanation in chemistry can be in the form of reaction, balance reaction. They like it. Explanation in math can be in the form of working. They like it. They accept it and like it. This is not English composition, in other words. Okay, no problem. No problem at all. Okay, Aiden, I'm looking at the current topic. So just to remind you, when you're typing, I can see that you're typing, but I don't know what you're typing. Again, it's like a chat, like a WhatsApp chat.
Oh, I thought I just like put it there already.
Just now, the moment you release your text box is the moment your chat appear to me.
Oh.
So it is really like chatting, isn't it? Like, oh, Aiden is typing, but I don't know what you're typing. Something like that. Let me show something. Let me do that to you. Let's see. Can you see that I am doing something?
Yeah, I can see the A.
But you cannot see what I'm typing, and yet I'm typing.
Oh.
Here I release. So see, now I release. Now I finish typing. Then only I release. Correct? How do I release? I just click outside, ting, and then suddenly it appears to me.
Oh.
You see that? Just like WhatsApp lah. Just like WhatsApp. Okay.
Yeah.
Don't be confused though. If you didn't release, I cannot see lah. Then cause some frustration. Okay, good. Okay, nice. Energy, power, current topic. Good. So, please write down all the topic that you have done, just to confirm lah.
Okay.
So you and Joshua are doing the same thing in physics, right? Pressure law.
Yeah, but I'm not sure why it's tested for my TA3. But if I want to go by the pattern, most likely not testing me the topics that weren't tested for TA2.
If there is a WA3 lah, which do you think there will be a WA3?
There always is.
So fair lah, fair. So going by the pattern, that should be the case. But remember, the SA2 will be everything. In chemistry, I am relaxed. I focus on your WA3 because I know those are the most difficult topics for SA2. I know. And make sure all these are correct. I'm happy. That's why I say, oh, you're good, no problem. Just take it normal from now. We continue doing papers. We don't care about the class tempo, something like that, right? But in physics, the next topic is the easier topic. I guess that's the good news. All the other topics before that are considered usually hard, and it will appear again in SA2. So our priorities will be slightly different.
Oh.
Yeah. Yep. Okay. Right. So Aiden, your choice today. You want to discuss pressure, or the next topic, or the past topics?
I think we'll do pressure.
Yep, pressure is tough. Joshua, what do you think? Is pressure tough?
Sorry?
Is pressure tough?
It depends. Really depends. If you got good teachers, I think it's quite easy. If you actually the teacher teaches you how to the basic of it, it's quite easy.
Really?
I don't know.
Good to know. I mean, you're catching it well. You're catching it well so far.
But yeah, it's okay. It's not that bad. It's actually easy.
Good.
It's not as bad as kinematics. It's not that different.
My first time hearing that. I hope that's correct. But you are doing well, though. You are doing well. Okay, good. Okay, pressure. So Aiden, again, let me confirm that you also don't have any homework or worksheet or practices on pressure.
I only have practices for kinematics from my teacher. I don't know why he gave kinematics.
Yeah, I also don't know. That is very confusing. I'm very confused right now.
Mm.
Okay, never mind. So your pressure, okay, I'm gonna draw something, right? So I have to find out where you are, right? So have you done this? Sorry, this kind of thing for pressure, this kind of thing? Nothing. Have
Yeah,
you?
I've seen that before, but I don't really understand that.
Oh, okay. So have you done this kind of thing? A small piston and a big piston kind of thing?
Yeah, I've seen that before myself.
Okay. Have you done well, most of them are the variation of these two, right? Okay, so have you done this this thing and then oh sorry. And then this is they ask you for the pressure inside this small place and that kind of thing. Have you done that before?
I think I've also done that before.
Okay. Now all of these are not in exam, is it? You have never you're not exam here in SA1.
This is not in the TA2 exam, but it will be in TA3 and TA4.
Definitely agree. I think our priority should be pressure. So the next time we meet Aiden and Joshua, if we ever meet, next week, we're going to spend some time talking about the energy, work, and power first, because it is not, hopefully it's not as difficult as pressure, right? Usually it's not. Then whenever we have time, we go back to strengthen your pressure. Joshua has been doing pressure all the holiday, so his pressure is reasonably good. Now, when we meet, we talk about the future topic, and then we quickly come back to pressure. Okay. So for example, today, this is not considered meeting. Joshua is almost done. Joshua started. So Joshua continue pressure. We also do pressure. Okay. Now, for the kinematics homework, Aiden, are you supposed to do it and submit it or what?
The teacher said that it's just to expose us to different questions, so we don't have to submit.
In other words, it's exam level?
I think he intended for it to be exam level, but I'm not sure if it's tested for TA3 lah, because if I go by his pattern, then it's probably not.
It won't be. It won't be. It won't be. It won't be. I'm asking so that I know that we can devote many time to pressure law and energy work power lah. That will stabilize your term 3 law. Since kinematic is not in term 3, we keep it, keep it back there for a while, and we immediately jump to it when your term 3 is stable.
Yeah.
Because it will be in term 4. And just to tell both of you, in case you don't know, you know that the term 4 exam, the SA2, is like, it's kind of close to the end of term 3. Like it's only 5 weeks after that. You know that?
Yeah.
Based on Sec 1, Sec 2, that's what's happening now. So in Sec 3, that it will also happen. And that's why we kind of stabilize term 3 right now and then prepare for term 4 almost immediately. So to speak. Okay, yeah? Again, for chemistry, easier because term 3 is hard. Then we just prepare for term 4. Okay. Okay, good. Joshua, you okay so far? Just checking. Because there's
I think I'm okay. Just more mercury is now added part. I think that's like the difference in height part. I think it's on page 11.
Oh, it's a continuation of 10, is it?
Yeah, sorry. Yeah, sorry. Continuation of 4. The previous one, the barometer one.
Oh, crazy. This question really is crazy, isn't it? Okay. Good questions. I mean, some people wouldn't like it. Okay, you think about it for a while. If you cannot do that one, do the air one first.
Okay, sure.
Okay, so now Aiden, how shall we go pressure? You don't have the worksheet. Okay, let me confirm one more time. You don't have any worksheet or anything regarding pressure right now.
Regarding pressure, I have slides from my teacher.
I want to see them because I want to know how your teacher teaches.
I will share the slides with you for pressure.
Okay, so yeah, maybe you send with me, Ken. You send. No. Oh yeah, you send with me. Sorry, you send to me first. Yeah, send to me. Correct.
It's quite messy though, because when I open up the slides with Google Documents, it will get very messy.
Send me in PPT. Look. I can at least open in PPT. Man. So maybe it won't be messy. I don't know. Let's try.
How to send to you in PPT?
Can you download it? When you download it, even though you download in Google Doc, but it should be in .ppt. Never mind. Just send me what you have. Just send me. It's okay. Just send me. Don't worry about the timing comments. Just send me.
Okay. Because I'm extracting it from like PDF from my class.
Oh. Never mind. Just give it. Just if it's messy, it's fine. For this question, Joshua, I don't even know where the mercury is added. Where?
I think it's like they just randomly added to the inside.
You see,
So the whole entire barometer.
adding it to the inside is not easy to do. That's why I'm a bit confused. I thought it is adding outside. I thought he has to specify, cannot they? Some air is introduced into the barometer at A. Now that he specified the placement. If I introduce air there, what will happen?
No, I mean I think what they mean. This is just my speculation. I mean they put in the whole entire. They just topped it up, if you know what I mean.
Yeah, that is also my speculation for the mercury, right? Which is annoying because you have to speculate. It is annoying. It's very
we don't know what happened to A and the other one, right?
For part 2 is A, right? Do you think you can do the part A to part 2 first? Is it?
I can do part 2. I did part 2. I'm just stuck on part 1.
Okay, so let me give you this way. So remember what the physics thing to follow is that your pressure equals to pressure, right? Here pressure must be equal pressure, here pressure must be equal pressure, here pressure must be pressure. That should be true even though we are adding more mercury. Okay. Oh, it's not easier, right? So if I add more mercury here, obviously, first of all, I think the mercury level will rise lah. So far, so good, yeah.
Okay.
The question is whether the mercury will suddenly go in here and influence the
yeah.
That's the question. But definitely outside it will increase, right?
Mm-hmm.
To keep it simple, as I increase the level, remember that the outside to inside is the pressure atmosphere versus the pressure inside, correct?
Yeah.
And because the level rises, now to be fair, I have a shorter liquid to fight, which is not okay.
So they'll have to rise.
Yeah. So the mercury inside will also rise. It's not drop, will rise in order that to have the enough height to fight the atmosphere.
Okay.
Keeping it simple, that's what will happen.
So that means it's the difference between the height is the same, then it will just stay constant because both of them have to rise, right?
Correct. Because if lower down rise, then the inside one also have to rise again because atmosphere stays the same. Okay. Eden, just confirm you're sending me something.
It's already been sent.
Send where is it? Sorry, is it WhatsApp or email? Sorry, I didn't realize that.
It's in the email.
Oh, okay. From now on, send using WhatsApp is just faster. Can you do that?
Yeah, okay.
Web WhatsApp lah. Are you using your web WhatsApp?
Yeah.
Okay. Please do that. Okay, it's just easier. Okay, let's give it a try.
I can't send it via WhatsApp.
Why is that so? You cannot drag it. Maybe. Can you drag it into the WhatsApp? It should work.
I can download it and
Yeah, you can download it. Yeah, I think it's easier rather than giving. You can also give me a link. Yeah, that might work. Okay, Joshua. Right. Okay. Maybe we have time for one more question, Joshua. Maybe.
Okay. One.
Thank you very much, Eden. Pressure. So I'm reading the oh, it's a PDF, sure thing. Right. Okay. I understand what you mean. Yeah, there will be some mess up, but in general, it's great. So I will share my screen. I'll share my screen, Aiden. You see my screen. I'm gonna share so that you can see the. Oh, you can see it now. Can you see it now? Can you see your PDF at my place?
yeah, I can see.
Okay. So I am looking through the slide. Let me just confirm that your teacher has finished all the slides before holiday.
Yeah, he has finished all.
Tell me how he uses the slide.
He'll just like display on a protractor in class and then he will talk about it.
So that is what he do, especially at the start of the topic.
Yeah, at the start of the topic, he'll do that. And then he'll give us some practice questions in like a blue color booklet and then we do it.
So you have your booklet in hand, your printed booklet. So then you can do it from there.
Yeah, but I'm really done with all the questions in there because they are done during like lesson time.
So he does it with you, something like that.
Yeah.
Why are you unsatisfied with your pressure?
Because number one, there's very less questions inside. Number two, I don't really understand it still. But because he does it in class, sometimes I just like follow with his class piece.
Of course. That is why we don't understand, but at least that is why we have the answer, at least, right? It's okay. This blue booklet is what you say, maybe sometimes the quantity of practice is not enough, and sometimes the quality, that means the difficulty, is also not enough.
Yeah.
That blue booklet is what you mean. Not enough quantity, not enough quality.
Yeah, I think so.
And then you say your teacher will give you more difficult or more practices, but a bit near the exam. So he gives you a separate sheet.
As in like he gives us like past year papers.
Which turns out to be more difficult than the blue thing.
Yeah.
Oh goodness. Now, give you an example. In Joshua's case, in Joshua's school, different teacher, different class, different. But in Joshua's case, Joshua, you have not started the pressure chapter, correct? Right? Have not.
We have, but like it's like very like we barely touched we barely went into the thing.
And your teacher kind of give you all the super practices.
Yeah.
And then the expectation is after holiday, he will discuss it a little bit, or he will discuss it. He will give it enough time, or do you know what's the expectation here?
I have no clue what's the expectation. She just wants us to do it, to finish it.
Which is almost impossible without understanding. So the only advantage Joshua have right now, Aiden, is that he has higher quality questions. Because he also don't really understand when we started off during holiday, right? Then we just continue building it up, right? Okay. In your case, I already understand what's going on. So I'm gonna go very quickly. That was fast. That was fast. Okay. 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 It's not bad. Have you seen this in real life?
Not yet.
Okay, then based on this slide, can you imagine that this is what happened? Or is the slide clear enough on what will happen?
The water level increases
Where?
inside the cup.
Outside the cup?
Inside the cup.
No, how about outside the cup?
It decreases outside the cup.
In the sense, the cup sucks the air, sucks the water in.
Yeah.
Which, of course, that's not what you're supposed to say, but it looks like that. It looks like that. Correct?
Yeah.
It looks like that. So the slide is quite clear. Now, can you imagine that happening actually?
I think I can.
Okay, all right. Oh, no, never mind. Okay. You can talk about that. I suppose you can talk about this. It's a very simple question there. Finally, we are here. All right, so starting here. Do you understand or not?
It's a bit harder somewhere here.
Okay. There's nothing wrong with the slide though. There's nothing wrong with the slide. The slide at this point is pretty much standard already. How about this one? Do you think you understand this one?
This one I understand.
So Joshua, just to confirm, no more question.
More questions. I think the rest are like mostly calculations.
Okay.
Yeah.
I'll be borrowing some of our questions lah for Aiden.
Yeah, sure. No worries.
Now, would you say that you should be done now with the pressure question at this point? Am I correct? Should be lah.
Yeah.
Right. So next week. Oh yeah. Oh, okay. So next week, is it okay? Oh no, but I want to talk about the future physics topic. So for next week, I want to talk about the future physics topic, the energy work power one. Okay. And I also want to talk about your chemistry deeper. Will that make sense?
Sure.
I request, I think 2 more extra, right? Yeah. Sunday, Monday and Tuesday, right? Monday and Tuesday. So the Monday, Tuesday, we'll use it for them. So there will be Monday, Tuesday, and Wednesday lah. Should be enough.
Monday, Tuesday, and Wednesday next week.
Next week. So Monday and Tuesday is in the 2 p.m. and Wednesday will be at the night lah.
Tuesday. Okay.
So we'll do that. We'll make your physics solid, and then we'll do a bit more on your chemistry.
Okay. Sure.
Thank you very much, Joshua. I'll see you.
Thank you. See you next week.
Okay, all right. So now you're looking at my screenshot for a while, right? You're looking at my screenshot for a while. Look at this question. Can you read the question? Is it clear enough?
A manometer contains mercury in one limb and liquid Y in the other.
Yeah, I mean you can read it, but what I mean is that, do you think you understand the question?
I understand what it's talking about, but I don't understand how am I supposed to solve it.
Okay, then I'll copy this to your Jamboard first, right? We'll use this for me to find out, your level of understanding, right?
I don't even know, I saw it before, but I forgot how to even do it.
Don't worry. I'll treat you as revising this topic. You in your slide, I don't think there is a whatever manometer is. Let's just think of it as this U-shaped glass tube. Okay, this U-shaped glass tube is totally old technology. We don't use this anymore. So partly the problem is that we don't get the physics from our common sense. We never see this before. I have to describe it in a way so that you understand. So not your fault. It's not your fault that you find this to be weird and cannot understand. There is no experience that helps us. Okay, yeah, that's clear first lah. It's okay. Now, however, I'm jumping right to this question. This glass tube, open and open, U-shape, contains two liquid. Okay, different liquid. Let me yeah, it doesn't matter where the mercury is. So at this point, I think the mercury is this one. Okay. There's the mercury. And there's the liquid Y. Part of the reason why this is old technology is because we don't play with mercury anymore, because mercury is rather toxic. But mercury was very important back then when they were starting off to understand things. So like, well, 300 years ago, mercury is still something very important. So we are talking about old technology, but we're talking about, this is going to be weird, the simplest way to understand liquid pressure. Okay, so as weird as this is still the simplest way, other than diving to the ocean yourself, which is very impractical. At least this thing can still show to students. Again, I doubt that modern lab have this. That is part of the problem. They cannot even show you in the lab, because mercury is already very difficult to buy right? Maybe 40 years ago, this will be standard in a learning environment. Right? So I apologize for that difficulty. I am acknowledging the difficulty that you're facing. Right? Let's help you out. Now, this is mercury, and this is liquid Y. Now, I'm going to talk about density immediately. Okay, so they keep telling you the mercury is very dense. They at least say that. Yes? No?
No, they didn't really tell me mercury is very dense, but I think it is very dense.
Very scary. Oh, it's very scary how they teach, right? So okay. Yes, mercury is very dense. Now let's give an idea about how dense, right? So let's compare it with water first, right? So there's a density of water water, I say 1 gram per centimeter cube. 1 gram per centimeter cube is very easy to imagine, right? So this is 1 centimeter cube, correct or not? Is that small? Yeah. A cube of 1 centimeter. Simple, right? If you have this small water, it's this small cube of water, it's 1 gram. It's 1 gram.
Okay.
It's 1 gram. Maybe you know, maybe you don't, but you certainly know what's kilogram. Do you know what's 1 kilogram?
Yeah.
1 kilogram is, I don't know, as heavy as half a watermelon, maybe half a watermelon. Now this is 1 gram, so 1,000 of 1 kilogram. It's a very small thing. Right? Now, the density of water can be rewritten as 1,000 kilogram per meter cube. What is 1 meter cube? Can you imagine 1 meter cube?
1 meter cube is
a cube of 1 meter.
Yeah, it's quite big.
Quite big. And that is 1,000 kilogram or 1 ton. 1 ton. Okay. So if you have 1 meter cube of water, you have 1 ton. If you have 1 centimeter cube, you have 1 gram. And surprisingly, borrowing from chemistry, this is the easiest cube to understand. 1 kilogram per dm cube. What is 1 dm cube? Do you know what that is?
dm cube is smaller than meter cube.
No. 1 dm cube is 10 centimeter cube. What's 10 centimeter? Around like that. Isn't this around 10 centimeter? 10 centimeter.
Yeah.
And this is the favorite unit in chemistry. It's not in physics, but in chemistry. 1 dm is 10 centimeter actually.
Oh.
10 centimeter cube, 10 centimeter, 10 centimeter, 10 centimeter is not big, it's not small. It is roughly your hand. Can you imagine it? Roughly, your hand, no? 10, 10, 10. Okay?
Yeah.
Can you imagine it?
Yes.
That is 1 kilogram. If
Yeah.
that's right. Now, another favorite thing is actually, tell you 10 centimeter, 10 centimeter, 10 centimeter is actually 1 liter. Now you can imagine 1 liter. It's quite easy to imagine 1 liter. 1 liter of water is 1 kilogram. Okay, that's water. So far, so good.
Yeah.
Now, how dense is mercury? Now you have a density of water to compare. Density of mercury in red will be 13.6 gram per centimeter cube, or 13,600 kilogram per meter cube, or 13.6 kilogram per liter. I am pretty sure this one is the easiest to imagine. This one is hard and this one is hard, correct?
Yeah.
This one should be easy. If you have 1 liter of mercury liquid, is 13.6 kilogram.
Oh.
For water, it's 1 kilogram. Think about it for a while. Is it, how dense is mercury?
It is 13.6 times more denser than water.
Correct. Which is, to me, it's crazy. I have difficulty imagining that, even though that is true. I have great difficulty. 13.6 kilogram is, I think, 1.5 times your usual bag, for example. Your bag is probably 7 to 8 kilogram.
Okay.
I think, I don't know how heavy but your bag is not, I don't think it's 15 kg. I don't think so. I think at most it's 10 kg. At most, when you're carrying a lot of stuff.
Yeah.
Of course, your laptop can be heavier, so but that is if you bring laptop to school. Not a lot of people do that, right? So 13.6 kilogram is like a bag, but in a size of 10 centimeter times 10 centimeter, like that's just super dense, no? No matter how you imagine it, mercury is very dense. Okay, and that is why it is useful. That's my opening introduction for mercury. It is liquid, it is very dense, and back then it is extremely useful. Not to mention, it doesn't react much. It is quite difficult to react. Just like when we talk about copper just now, remember I talk about copper can react with acid, actually can, but it takes 1 day. It's very slow.
Oh.
Mercury, even slower than copper, even better. So in some sense, you can appreciate a certain quality of mercury that you know, people long time ago find it useful before there are modern alternatives, especially the heavy part and the not reactive part. Okay, okay.
Yeah.
Now, this heavy liquid is now in the glass. Now let me draw another glass first, right? Another glass tube. If it is liquid, it can flow around now. So that's another like crazy good thing about mercury, right? It's just nice. It's just nice to use back then. The only drawback is it is poisonous. And it's expensive, but you know, poisonous is worse. So if there is only mercury inside, there is no liquid Y, okay? There's no liquid, just mercury. Is it possible for their leg to be different in height?
No, it will always be the same.
Okay, now let's pretend I managed to push this liquid, don't know how, lower, then this liquid obviously go up, right?
Yeah.
If I release, what will happen?
It will drop back to the same length.
Correct. It will maintain the same length because why? If this is lower and this is higher, then this will push this. Correct or not?
Yeah.
And this is pushes too far, this is higher, this is lower, you'll push it back again, you know, until finally we are in the same position. That simply makes sense, correct? That simply makes sense. Now, look at this guy. Different liquid, and the height is different. Isn't that crazy? What does this mean? They are steady, you know. They are steady here. They're just steady at this situation. Mercury is lower, liquid Y is higher.
Yeah, so that means that mercury is denser than liquid Y.
You are absolutely correct, because among many explanations, if I draw this line, this amount of mercury will have the same weight as this amount of liquid. Look.
Oh,
If more liquid is needed to balance mercury, right? Remember, okay, I'm pushing you down, you're also pushing me down. Yeah, both are pushing down, correct? Okay, but we are in a standoff when we balance. So this liquid Y, correct, must be less dense, because I need more volume, more volume to balance the mercury. Only then this amount of liquid will have the same weight as this amount of liquid mercury. Okay.
oh,
Make sense?
yeah.
I'm not asking you to memorize formula. You use the formula, right? Just like Joshua, I'm asking you to use your logic first, right? And both of you have good logic, so it's a shame if you don't use it. If you just equate logic with formula, that will be a mistake. Look at the option. Immediately, certain things are gone, right? Which one is gone?
Immediately, 20 is gone.
Correct. How is 20 possible? Cannot be lah. Make sense?
Yeah.
I will draw your attention to this is 8 centimeter and this is 12 centimeter. Okay, Ken?
Yeah.
It doesn't exactly tell you the volume of mercury and the volume of liquid. You may wish you do that, but remember that this cross-sectional area is the same as this cross-sectional area. Just saying. Okay, just saying that. The shape of this liquid is a cylinder, ma. This is also a cylinder. Their cross-sectional area is the same. They feel no need to give you the cross-section area. They just feel the need to give you the height. Just want to point that out. Yes?
Yeah.
Now, use your logic, not formula. I don't care about formula. Use your logic and tell me which answer is correct.
Density of mercury is that it's not C.
Okay, sure.
It's B.
Your final answer is B.
Yeah.
How do you, what do you do so that you get 9.1?
Because like 8.0 is 2 over 3 of 12.0. The 9.1 is the closest to that.
And just press your calculator to check. 2 over 3 times 13.6, right? Just check lah.
2 over 3 times 13.6. 2 over 3 times 13. 9.06666667.
Which is 9.1.
Yeah.
Okay. Now, if you are correct, then you should be happy. You should be happy. You shouldn't be happy just because you find a number on the option. You understand me, right? You might still be wrong, right? Okay. It might be a trap, right? So are you correct or not? Well, I can tell you that you are correct. If this is an MCQ question, you don't have to work it out. Your logic is correct. Our logic is not always correct, but in this case, you are correct. I'll show you the proper working so that your logic can now combine with the proper formula.
Okay.
One more time. Logic is not above the formula. Formula is not above the logic. It must be both.
Yeah.
Okay. If you want to memorize things, you shouldn't be attending tuition. If that makes sense, right?
Yeah.
If you want to understand things, then maybe this will be helpful. So now let me show you the proper formula. Let's see whether it is making any sense. So I purposely take this line. In this line, I say this is I'll say that this is point C because they already tell me, and I'll say this is point A just to make my life easy. Okay? Force at A caused by mercury. Force at C caused by liquid Y. Force A downward must be equal to force C downward. That is my first physics.
Okay. Yeah.
Force at A is caused by liquid. Okay, never mind. First of all, pressure A times area A will be equal to pressure C times area C. Okay.
Yes.
Area A and C is the same. I cancel. That's a favorite thing to do in favorite thing to do in physics lah. Can cancel lah.
Yeah.
From force A equals to force C, you are at pressure A equals to pressure C. Think about it for a while. Do you understand this? Do you think you understand?
I think I kind of do.
All right. Now we go to liquid law. Before I go to liquid, I'll tell you something first. Pressure, area, force formula, right? You know this formula, the most basic formula in
Yeah.
pressure, right? This appeals to everything. What I mean by everything is solid, liquid, and gas.
Yeah.
Whether you're solid or whether you're liquid or whether you're gas, this works. The next formula, rho GH, only works when you're liquid. Right?
Oh,
There is a difference in the how to use the formula. That is often not said clearly. Sometimes people make the misunderstanding of, oh, this FPA only works for solid. That's wrong. It works everywhere, everything. But now rho GH only works in liquid. Now I'm using rho GH because it's liquid law. Okay. By the way, this is rho of A, which is mercury, H of A, which is mercury, rho of C, which is don't know why, and H of C, which I mean, at least they are given. The G can cancel, favorite stuff, right?
yeah.
Now, what are you trying to find here?
The question is trying to find the density.
Right, density of who in the, in this formula?
Why?
Rho of C lah, we'll just call it like rho of C lah, correct? Rho C lah.
Yeah.
So rho C will be rho A, which is, the mercury, correct? 13.6.
Yeah.
HA over HC, which nicely it is 8 over 12 or 2 over 3 log. Then that was your logic back.
Oh.
Let me repeat this one more time. I'm not saying that your logic is superior. Just use logic. I'm not saying that formula is always better. Who knows your logic is wrong? I'm saying that your logic and the formula is the same. They give you the same thinking, and that is very important. Formula shouldn't counter your logic. Logic shouldn't counter the formula.
Oh.
That is
Okay.
where you feel you understand better. Correct or not?
Yeah.
If I ask you to do formula first, then use logic, you will feel that the formula is stronger than logic. You will refuse to use logic. I have formula already, what? But
But if answers were like very close together, then like you had to use formula.
I'm sorry, you're saying?
But the options are like very close together, then you need formula.
You're of course correct. And if it is a short answer, you also need the formula. But do you understand the formula? What makes you comfortable with formula is not that you can just use it, but also you feel that it makes sense or you understand it. Not that you understand the formula, but you understand the situation. That's what I'm trying to explain. You understand the situation. Then you use the logic. You're not using the formula. Then when you use the formula, you find that it agrees with your logic. You feel better.
Oh, so when I do a question in the exam, I use my logic first, and then I use my formula to check.
That logic is always the first thing because you understand the question by logic, not by formula.
Yeah.
Let me put it another way. People say you can just plug in the number into the formula. Yeah, but those people who say that, are you sure they're scoring very well?
I don't know.
Of course, you're right. Does your teacher ever say that? Just plug in the formula, man. What's so difficult? He never say that, right?
No, he never said that.
When you do that, when you approach a topic in physics, maybe because you don't understand, you just approach it with a sense of just plug in the formula, right? How does that work for you?
I don't know, that sometimes can be a bit easier in the sense that when I see like F, then I just put F as like formula.
Yes, of course, true. I mean, a formula must always be plugged in properly, but you don't understand the context, you don't understand the question, you just look for plugging in formula. How does that work? Does that work very well for you in Sec 3?
I don't think it works very well.
Because pure physics. Yeah. if you go take combined physics, there is a likelihood that it still work very well. If you go back to Sec 2, I think it'll still work very well. It's because of pure physics. Okay?
Yeah.
So we train your logic so that your logic understand the question, and then using the formula becomes more of a joy. I guess we can say that. I guess. Okay. Even if your logic is wrong, you can counter check with the formula. One more time. I'm not saying that logic is better. I'm not saying that formula is better. I'm saying that both should work together.
Yeah.
Now, can I erase the working and you do again, or maybe I'll copy it to the next page and then you do again?
Sure, I can try.
Sure, but you do it on paper, lah. You do it on paper. Easier. Then take a picture, send to me. Happy then.
Don't have like paper to do it on, like near me.
You just grab a piece of paper. Right? For now, lah. For now, what else can you do? Right? I cannot follow your work. Should you tell me if you have problem? Right?
Yeah, okay.
Are you okay so far?
I am taking the picture.
Oh, okay. Then once you take it, I'll put it in, right? For now, that's what we do. Okay, good. Yeah. Okay, it feels like there's a jump in the end, but as long as you understand, it's fine. Right? Okay, I'm putting it in here. Okay. Again, are you sure you understand this question?
I'm not entirely sure. Like, can't I just start with PGH without using all the F and thing at the top?
Okay, first of all, it's not PGH. First of all, it's rho GH. This is rho. Yeah, it's a rho. Yeah. That one looks like a P. Yeah. Yes, you can start with rho GH, meaning you start with pressure equal to pressure.
Yeah,
Yeah.
pressure equals to pressure means force over area equals to force over area.
Correct. You can. There's no problem with that. I'm just doing it from the easiest thing to understand. I feel that it's easiest to understand. Remember, I was explaining to you, your teacher will start with rho GH1 immediately. Okay. And then oh, formula very powerful. I mean, correct lah. Let's see how you apply it in the next few questions. Let's see whether pressure equals to pressure is easier to think about, or force equals to force is easier to think about. Let's see lah. Let's see. To be fair, we are much more familiar with force, you see, than pressure lah. Okay. I'm not saying that you cannot, by the way. Of course you can. Of course you can. Teacher won't complain if you start not from force. Yes, teacher won't. Okay, I'm talking about logic. Right.
And then for this part where it's like AA and AC, is it cancelled off because like you just now you mentioned the cross-sectional area is the same, so you can cancel it?
Correct. And then suddenly you have pressure equals to pressure.
Oh.
But again, do you prefer I say pressure equal to pressure, or do you prefer I say force equals to force first?
I think both is fine because like the formula is interconnected.
And that, if that is fine, then that will be fine. Okay, as long as the logic is fine. Okay. Anyway, they are correct for now. Okay.
Yeah.
Right. Let's probably borrow some more of Joshua's question. Right. So, oh yeah, unfortunately, sometimes we just cut the question. That's not very nice. Oh, there you go. Yeah, this thing. Okay. So you can see that the page is a bit blurry, right? Okay, blurry. It's because I screenshot from the Zoom. That's how we do intuition, right? Right. So this is already longer, so I'll just copy and paste in yeah, should make it smaller. Oops, wrong. And it's also a bit slanted. Why? Yeah, because it's a it's a Zoom camera, a bit slanted compared to the paper, right? Oh goodness me, this is so slow. Sorry, I'm trying to make this smaller. This is not happening. What's going on? Never mind. Just copy it like this. And you see that it is his original writing. That means I'm looking at it from a paper. That's what you should have when the phone stand arrives. So much faster. I think you gotta ignore his working for now and just read the question. Right? Okay, very slow, super slow. Okay, there you go. Now, please read the question and let's try to understand it first.
What level between two is height? It's quite blurry for me.
Correct. So a U-shaped tube, okay, nothing fancy, right? Containing water, shown in figure, nothing fancy, as a manometer to measure pressure from a gas outlet. Now he is now using this weird manometer thingy to measure the pressure of a gas, which is supposed to be in a container. The container is connected to this end. That's how you measure pressure. Okay, that's left out in the picture, so that might not make a lot of sense. Okay.
Yeah.
Just imagine it that way, right? This hand is connected to the gas. This hand is open. How do I know? Even though the picture is blurry, because he's pressure, so it must be open, right? Makes sense, huh? Good. Then the difference of water level turns out that this is inside is not mercury, but it is water. Surprise. There's a difference between A and C, and the C is higher by delta H. Delta H means he's not giving you the number, okay?
Yeah.
When the first cylinder of gas is connected to tube A, the difference in water level is 0.05, and surprisingly, he changed cylinder. Would that be okay? There are two different cylinder gas, no?
We disconnect this gas and put another gas over it.
Something like that. Something like that. He only showed one picture though, so that might be a bit confusing to some of us. Fair enough. Only when you read the question, then you start to, oh, I understand. A little bit annoying, but that's what they do. So it turns out that they tell you the delta H for the first cylinder, and then the delta H for the second cylinder. There you go. He tells you all.
Then why do they even use delta H if they already like tell what it is?
Because he just wants to draw one page instead of two. He tells you the second cylinder, the delta H is different, man. So you don't want to draw both lah. That's why he used delta H. Would that be okay?
Yeah.
So that is the situation. Does the situation make sense for now?
Yeah, it makes sense. So this means like the gas is denser than the atmospheric pressure.
Because it is pushing back the atmospheric pressure.
Yeah.
Now, how about the first gas and the second gas?
The first gas is less dense than the second gas.
Okay. Now, for now, we will use a different term. I understand your density. I mean, I almost like it. It is wrong, but it has some logic. Wrong doesn't mean no logic. Now, we will use the word pressure, which is more appropriate. But again, I like what you're thinking. The first gas has more or less pressure than the second gas.
The first gas has less pressure
than the second one. So the second one, highest pressure according to you. The first gas, slightly lesser than that. And how about the first gas compared to atmosphere?
The first gas is more than the atmosphere.
All right, higher pressure. So just like that, I think the logic is already enough to try to answer A. Okay. Do you think you can try to answer A?
Write down the expression for the pressure of gas in the... Oh, the answer can be written as like rho plus something.
No, it's not rho. This is P. Then pressure is P, a bit different from rho, right? So here, a bit blur, but the atmospheric pressure is written as okay, it's not rho, it's P.
Oh. So the first sentence should be like PO plus.
Plus.
I mean, his answer wrote 500.
Yeah, I know, but I mean, ignore that lah. How did he get 500? The point is, however, your logic is your logic is like the same as Joshua, right? You're saying that first cylinder higher pressure than atmosphere, so PO plus something lah. Okay, at least there's some agreement here. Correct or not?
Yeah.
The question is plus what?
Plus this value here. The 0.05 meter, I think he converted that to like
pressure lah.
How do you convert meter to that 500?
That shows that you have yet to understand the formula. The formula for the pressure of liquid is rho GH. I'm giving you a hint. Not the full answer. What do you think?
Rho GH. What is the G again? G is gravitational strength.
Yeah, which is as 10. It's a constant. So I mean that's the easiest part.
So the G cancels each other, then it's P.
The G cancel each other when there's one in the left and there's one on the right. Don't be so hasty to cancel things. You cancel things when there are two things, right? Two same thing, right? Are you sure you can cancel things right now?
Like rho GH of the gas and rho GH of atmospheric pressure should be the same because they are both on Earth, right?
Atmospheric pressure, no need rho GH. It's already P naught, first thing first lah.
Oh.
Okay. That's why we say the rho GH is usually just useful for the liquid part.
Then how he convert that to 500?
Right. So again, how does the logic start? How does the physics start? It's not the formula. I'm sensing you just jumping the formula, right? Your physics is not solid yet. Your logic is not solid yet. Not enough. Not enough. You're jumping the formula. Now, I will take this line. I will take this line and say, same thing. What is pushing here is equal to what is pushing there. That's logic.
Oh, so force A equals force C.
Same thing, and therefore area the same. So pressure A equals to pressure C. Again, we are at the same spot, right? Pressure A equals to pressure C.
Yeah.
Now, who is pressure A?
Pressure A is there's two pressure A.
No, there's only one pressure A. Who is pressure A?
The gas.
Yeah, pressure A is the pressure of gas. Oh, the one that we are trying to find. No, okay, that's pressure A. Okay, happy. I'm trying to find pressure A. Can?
Yeah.
Pressure A equals to pressure C. Now, C is here. Okay, because actually he say okay, never mind. So C should be defined as here. Careful. Just that's C. That's C. So what is pressure C?
Pressure C is rho plus this delta H.
No, zero. No, it's not rho. Is pressure zero. Pressure zero is the pressure atmosphere.
Oh, I don't know. I keep seeing you go like.
Yeah, it's not rho, it's P. Yeah, it looks like rho, but it's not. It's P because atmospheric pressure, so it must be P. So P naught or P atmosphere again. It must be P atmosphere and then what?
Plus delta H.
Yeah, so we don't say delta H. Of course, logically that makes sense. But you say the additional weight caused by the liquid law. So in C, atmosphere is pressing downward. The weight of the liquid is also pressing downward. Correct? So
Okay.
pressure of atmosphere plus the pressure caused by the liquid. Make sense?
Oh, so it's atmospheric pressure plus liquid pressure equals to pressure A.
And does that make sense?
Yes.
They are pushing each other at equal strength. So that's why nobody's moving.
Yeah.
So again, your question is how to convert delta H into pressure. Well, then comes in the formula law. The logic can stop there. The formula can take over. The pressure of that liquid will be rho G H.
Yeah, but rho G. Huh?
Yeah, one more time. What is the rho of the liquid?
If it's just water, then it's 1.
It's 1 gram, but in this case, we are using meter, so we should be using the 1,000 kilogram per meter cube. Would that be okay? We're using 1,000 here.
Yeah.
And that's the 1,000 for rho. So G is 10, right? Then H will be?
H is 0.05.
Meter. So you times all of them, you get?
Times by what?
Oh, wait. It's like you're very confused with rho GH. So the pressure of that liquid is rho GH, 1,000 times 10 times 0.05.
I actually don't get how like GH thing works. Like how can you use rho GH to like find like 500 from that?
Oh yeah, I'll tell you. If I'm not mistaken, your slide do tell you that. So let's see. Why is rho GH a pressure? That's your question, right? Why? Okay, let me show you. Pressure is caused by the weight of the liquid over the surface area. And that's what the pressure is.
Okay.
Weight is mg, right? Just saying from A.
Okay.
M is density times volume, G over A.
Okay.
The volume is the volume of the cylinder. I mean, the shape of the liquid is cylinder, correct? Cylinder. Okay.
Yeah.
So rho, the volume will be the height times the surface area in the circle, right? Height area, G over area. Will it be okay?
Where did H and A come?
Volume.
Oh, times area.
Volume of cylinder is the height of the cylinder times the, the cross-sectional area of the cylinder.
Okay.
Would that be okay?
Yeah.
Cancel A. They are the same A. I have rho GH. Then
Oh,
I go from pressure, which is weight of the liquid over area of the liquid, which you make sense, right? That one makes sense, correct? One makes sense. And then I simplify until I get rho GH. And then they introduce this as a better formula to use.
oh. So I sub H with 0.05.
Meter, yes. And then G is 10, and then rho is, well, the density.
Oh, the density is like 1,000.
In this case, because we're using meter, right? Depending on what we're using, we'll use either 1,000 or 1, depending.
Oh, okay.
Right. That's also a slight confusion, but it's not very difficult. Just pay attention to the unit.
Yeah.
Okay, and therefore, the pressure of the first cylinder will be atmospheric pressure plus rho GH. The rho GH in that case will be 500.
Yeah.
Okay, second cylinder.
Gas cylinder is 1,500 because it's the same logic as just now.
Oh, that's correct. And that's why the answer is P naught plus 1,500.
Yeah.
You understand so far?
Yeah, so far I can understand.
Right. Now think about this carefully. Is this an improvement? Like is this more understanding than what
Yeah, this has more understanding.
we are already going. No, this is just slightly more complicated than your slide. If you look at your slide for a while, your slide contain this thing. See, pressure, right?
Yeah.
Same situation. The question from Joshua, see, same thing, right? See, same thing, right? Look at that.
Oh.
Same thing. Now you understand the slide. Now, furthermore, the question just now is only slightly more complicated because he switched gas supply.
Oh.
Right. Okay, so you're already here. You are here. I noticed it just now. Right here. You may not have seen gas pressure, then suddenly the left-hand side higher. I mean, it's not very complicated, but you are definitely at this slide. Confirm already. Okay.
Yeah.
Whether you understand the weird units, CMHG or whatever, that's later. Later we can talk about. Okay. Okay. Any question before we move on?
So far, no questions about this nanometer.
Right. So you don't have to redo it also because it's not very difficult. Right? There's no need to do that. Never mind. I'll just copy it for you. Never mind. Let's just finish it, right? Okay. So still the same question, but okay. Take a read and give it a try.
Where is tube B?
Sorry.
Where is tube B?
That's a very good question. I think tube A means the first. Oh yeah, tube A is the first cylinder. Tube B is the second cylinder, I think.
Oh. Oh, it's 0.1 meter.
0.1 meter. You are correct. Do you want a discussion or that's enough?
Yeah, I think I can understand why it's 0.1.
Correct. Then last one. If a U-shaped tube with a bigger diameter is used.
It will decrease because like bigger tube means that like the height will need more volume of water to increase.
Right. Let me clarify first that it means that both leg, there's a left and right leg, right?
Yeah.
Both leg increase in diameter, okay? Both are bigger lah.
Yeah.
And bigger means both still have the same area, just bigger. Okay. So
Yeah.
you're saying that there will be a change lah, it will decrease or something like that. Yes?
Yeah.
And you would be wrong. And let's understand why. What is important is to understand why, right? Okay, so here's the original thing. And then here is something bigger. Okay, we'll just make it very bigger, but both legs still the same, right? Now, of course, you are correct that you need more liquid. That much is true. But you're saying that because more liquid, then the delta H will be lesser, right? Okay, let's see whether that's true or not. Now,
Not true, it will remain the same.
So which one is your answer? Which one?
Remain the same.
Okay, then let me just make it very clear what will happen. So now I'm drawing the tube. Now, what you are right is that, first of all, the liquid will drop because, the liquid needs to fill, a bigger tube. So right now, without anything, this is empty and empty. The liquid is now like very low like that. Because again, you need to fill a bigger tube, which is why we don't like a bigger tube, like a waste of liquid. But that is what will happen, okay?
Yeah.
But now we put in the gas again. So remember, gas A here. This is still atmospheric, right? A, right? So remember, since gas A pressure is gas A is atmospheric plus 500, correct? 500 PA.
Yeah.
So there will be a change in liquid. So this one will be lower and this one will be higher, right? This one will be lower and this one will be higher. And the question is, what is this delta H lah? So obviously the delta H will be 500. The cost of the 500, correct? The delta H will be related to the 500 again, because in the left hand side this will be P naught plus 500, and on this the left hand side will also be P naught due to ATM plus delta H G and rho, correct? Rho GH. Same issue, rho GH, and then the rho GH will be equal to 500. At this point, G is still 10, rho is still 1000, so the H will still be 500 over 0.05 meter. So the delta H will be the same.
Oh,
Right? Okay.
Yeah.
Do you need me to put it another way, or is this acceptable?
yeah, this is fun because this one is saying like the rho and the G is both constant. So that's how the H
Right.
is.
So the H will still be the same, no? Right?
Yeah.
Of course, the whole liquid will drop first. That's of course true. The whole liquid will drop, but after that, when you install A, the delta H is still the same. It's just happening lower there instead of the initial height. That's all. Okay.
Yeah.
Okay. If that makes sense, then good. So far, good. Right. We have 5 more minutes. Right? Oh, right. This one. Okay. This one. Okay. Better copy it for you. Okay, so Aiden, kindly read this question, and this can be our last one for the day.
Figure 10.1 shows two. Yeah, I've read the thing. So like, what's the question?
All right. Are you sure you understand the situation first?
Yeah.
Okay. Now tell me, before we look at the real question, how can this guy be higher than this guy? Does that even make sense?
Because they said like the pressure up there is negligibly small.
Okay. And the better word for that is vacuum lah. Okay.
Oh,
Vacuum means no pressure lo. Again, this means that the pressure here, and negligibly small, no air, no pressure. Okay.
Yeah.
Now again, why is that is higher than the other one?
Because the other one has air, so therefore there is pressure pushing it down.
Not zero lah, right? Pressure bigger than zero. Okay.
Yeah.
So I hope this makes sense that if this has a pressure and this has to be higher lah, right? It has to be. So I am willing to bet he's going to ask you the pressure in Q. Willing to bet. What is the pressure in Q? I haven't seen the question. I think that's what they're going to ask.
The pressure in Q, rho GH.
Sure.
Rho GH.
I mean, rho GH is easy to say. I hope you're not jumping the formula, right? I hope not. G is 10, right? So what's rho?
13.6 times 10, 3 kg m minus 3.
So 13,600, right? Okay, that's the rho. Okay, then what's the H?
The H is 0.15.
meter.
Yeah.
You are correct, right? Never mind the final answer. Do you know why? Do you need explanation?
Because when this is a vacuum, then this one is technically like nothing. So like this one will always be like greater than like the value here. Like
True.
0.15, the difference here.
Right. So in other words, I think what you're saying is, looking at this line, he is pushing in the same strength as this liquid. Look.
Yeah.
This air is pushing in the same way as this liquid. This liquid is 0.15. Okay, correct. Look, easy. Look. You are correct. The pressure of the air here is the pressure of the liquid here. Please don't misunderstand this. This doesn't mean that you can calculate the pressure of air using rho GH. You weren't. You were calculating the pressure of liquid here, which should be the same as the pressure of gas here. One more time, pressure of gas cannot use rho GH1. You're just equating the pressure of gas with the pressure of liquid here. Am I making some sense?
Yeah.
Okay. Without this liquid, you cannot use rho GH here. Another way of putting it. Right? Okay. I would say happy for today.
Oh, okay.
There should be more. There should be more difficult questions, but that can wait. Okay, that can wait. Okay.
Yeah.
I am also happy that I can talk to you about physics, so I roughly know where you are lah. Roughly know, right?
Yeah.
For next. Oh yeah, for next week, shall we do the same thing lah? Is it same thing means Monday, Tuesday, Wednesday, and then let's call it a week lah.
Yeah, next week we do that as well.
Yep. So for physics, if we end earlier, then we'll just end earlier, right? If physics you need less, that's good news. That's fine, because chemistry is I'm reasonably happy already.
Oh, okay.
Okay, so let's stabilize our physics. So again, stabilizing means what you feel in chemistry. I mean, do you feel stable in your chemistry right now?
I feel like my chemistry still isn't like that good, but it has improved lah.
Stable means your term 3 will not be unstable.
Yeah.
Okay, never mind. We'll see whether that's true or not in term 3 lah. You'll see for yourself, right? But I think you're fine. Anyway, if today is the end, I will see you next week on Monday. Yes.
Yeah.
Okay. And your school day thingy. Wait, have you said yes already? Wait. Yeah. I asked you whether you can do it on Monday. So kindly check and tell me when you are sure.
Yeah.
Okay. I will see you next week, Monday, Aiden.
Okay. Bye.
Bye.